All right. Hello, ladies and gentlemen, and welcome to Unit 5 Respiratory System, Day 4. And today we're talking about disorders of the respiratory system and how they affect homeostasis. So, obviously, our respiratory system is responsible for the intake of oxygen and release of CO2. And which brings us to our do now question. What essential process occurs between the alveoli and capillaries? That is gas exchange. Right? The process of gas exchange occurs between the alveoli and the capillaries. So let's talk about disorders of the respiratory system. So, asthma is the constriction. Here you can see sort of the collapse of these bronchial tubes occurring, narrowing the passageway for air to flow to the lungs. This is a childhood disease, can be fatal, but it's well controlled with medication in the United States. Bronchitis is inflammation of the bronchial tubes that causes mucus buildup. So you can see this is unlike constriction, which is caused by inflammation, but it's more of a collapse. This is inflammation that is swelling, causing a mucus buildup, more similar to an infection. So asthma is more similar to like anaphylactic shock or an allergy. And this is more similar to an infection. And some people can have what's called chronic bronchitis, which means they have mucus in their lungs all the time. And you can especially get that if you are a smoker. Speaking of things that you can get if you are a smoker, let's take a look at emphysema. And you can see there someone with emphysema, their alveoli begin to get destroyed. So you can see the alveolar sacs are collapsed, which limits the area for gas exchange, which means they're not able to take in as much oxygen into their blood or release as much CO2. So they're not able to make ATP as quickly or as efficiently. And as a result, this doesn't just impact the respiratory system, but this has a major detrimental impact on the life of the person. It's considered terminal, meaning this maybe not right away, but eventually it kills you. It's a gradual reduction and breakdown in the amount of alveoli in the lungs and is almost exclusively caused by smoking. Usually results in coughing of blood and pieces of your lungs due to alveolar death. Not good. All right. And now we're talking about the respiratory system in 2020. We got to talk about COVID-19. So, respiratory infection caused by the novel coronavirus. Many people show many different symptoms, which include shortness of breath, coughing, wheezing, loss of smell and or taste, fatigue, muscle weakness, congestion, nausea, diarrhea, and in some severe cases, death. Some people are asymptomatic, show no symptoms at all, and it is passed through respiratory droplets from breathing, and it is airborne, which is why we all need to, ooh, ooh, forgive my atrocious doodle, wear our masks. Okay, so how is the virus transmitted? A single sneeze can produce up to 10,000 droplets. Oh my gosh. A single cough can reduce up to 3,000 droplets. So even wear your mask when you're at holiday parties with your friends and family, which we shouldn't be going to, but it's a sad time. So a virus becomes airborne and can be suspended in the air in very tiny droplets for hours. If the droplets land on surfaces, the virus may survive for as long as 24 hours on cardboard and up to 3 days on stainless steel and plastic. There's nothing for you to write for any of these except for take some additional notes like I did. But How do disorders of the respiratory system impact the body's ability to maintain homeostasis? Impact the body's ability to take in oxygen and release CO2. This impacts the body's ability to complete cellular respiration. All right, ladies and gentlemen, that is how do disorders of the respiratory system affect homeostasis. Short and sweet today. I hope you have a super fantastic day. Don't forget that there actually, an important thing to note, there is no exit ticket here for this worksheet. So go forth and I'll see you all on Zoom tomorrow for the lab, making connections. We'll have a good time. All right, see you then. Bye-bye, guys.